Okay, so welcome, and so what we're going to do is, this is a class on linear algebra. This is Introduction to Linear Algebra. I'm going to jump right in. A lot of these videos are going to be short and sweet and to the point. Please watch these videos. Also, the videos go along with the textbook, but these videos can also be used with pretty much any textbook because they're pretty much the same order, the same material. So with that being said, let's jump right in and let's talk about linear algebra. Well, where does linear algebra fall? Linear algebra is used all over the place. Many applications in the real world, in physics, economics, chemistry, sciences. You know, linear algebra pops its head up all over the place. And so I'm going to give two examples. So the first example is we're dealing with balancing in statics. So in statics we have, let's say we have these weights, and we've got these two situations that we found through experimentation that these weights balance perfectly on this fulcrum. Okay, now the thing is these are all in kilograms, okay? And the distances from the center is in meters. Okay, so again we need to have hold on, is it meters or centimeters? Hold on. Meters. Okay, so these are meters. So, so a couple things. We found these two different situations, these two different arrangements of the weights where they balance perfectly. Okay, and we've got the distances here of each weight from the center of the fulcrum and over here. Okay, now, what do we know? Well, we know that this is a 2 kilogram weight, but we don't know these two weights, and that's what we want to find. Okay, now, one of the things that we're going to use, and again, you may not know this, but again, one of the things that we're going to use in this situation, statics, is we're going to use the idea of moments. What is a moment? Well, again, moment, maybe, you know, this is not a physics class, but a moment is the product of the weight times the distance it is from the center of the fulcrum. So in this case here, we've got H and C. Those are the weights that we want to figure out. We don't know what those are the unknowns. And so what we're going to do is we know from physics that the moments on one side of the fulcrum should add up to the moments of the weights on the other side of the fulcrum if it balances. Okay, so that will help us figure out a system of linear equations. How do we do that? Well, we take this weight h, right, or mass rather. So we take the mass of this object times its distance. So we're going to do 40 times h plus c times its distance, which is 15. So 15 times h, and that's going to equal the moment on this side, which is 2 times 50, which is 100. Okay, so there's one equation. Now if we go over here and we look at this situation, we do the same thing. So we take c times 25, so 25c equals what? 2 times 25, which is 50, plus, and then h times 50. Is that right? Hold on. Yeah, that's right. So let me make sure I have my numbers right. So 50 times h. Oops, hold on. This is c, not h. Okay, c. Okay, so now, there's our two setups. Okay, now, that gives us our two equations. So now we have a system of equations with two unknowns that we can now solve and find out what the two unknown masses are. Okay, so there's one. Now the second example is from chemistry. So this is a chemical reaction Okay, so under certain controlled circumstances, we could take these two products, or these two chemicals, right? So here we have toluene. So we have toluene, and we can mix toluene and, what is this? This is, nitric acid, okay? So we could take toluene and nitric acid, and if we mix them under controlled environment, controlled circumstances, we can have them mix, and we can get two other products, which is going to be trinitrotoluene, in other words TNT, otherwise known as TNT. So trinitrotoluene, and one of the byproducts is water. Okay? Now, as you notice here, we've got these coefficients here, these variables, that are unknown. And so one of the things is we want to figure out balancing a chemical reaction. Okay? So we want to find out, how do we do that? Well, this is where we're going to come up with another system of equations, because what do we have to do? Okay? In what proportion should we mix them in order to get this to work out? Okay? So the number of atoms in each element present in this here are given here. So these are the number of atoms, right? So we can see the number of atoms of nitrogen, hydrogen, oxygen, and carbon. Okay? And so we're going to figure out a way to balance these. Okay? So they must be equal before mixing, and after mixing, everything should balance out. Well, that means we're going to have to come up with a system of equations to do that. So, let's look at carbon. Well, over here we have 7 carbon atoms, okay? And over here we have 7 carbon atoms, okay? But here the coefficient is X, here the coefficient is Z. So that'll give us our first equation. So we're going to have, the first equation is going to be X times 7 has to equal 7 times Z. Okay? Now, what are some of the other things that we have here? Well, let's see here. Let's look at hydrogen. Hydrogen, what do we have? We have X times 8 hydrogen plus Y times 1 hydrogen, right? So that's going to be on this side, so that's going to be X, so it'll be what? 8X plus Y, because there's only one. That has to equal what? How many hydrogen on this side? Well, we've got 5 times Z, so 5Z plus 2 times W. Okay, so there's the second equation. Okay, now we're going to look at nitrogen. Okay, nitrogen, we've got 1 nitrogen over here, so that's going to be Y. And that has to equal what? Well, we've got 3 nitrogen over here times Z, so it's 3Z. And that's it, because there's no other nitrogens over here. And the last one is oxygen. So then oxygen, we have 3 oxygen atoms over here, so it's going to be 3Y. There's no oxygen over here, so we go equals, and now we've got 6 oxygen here, 1 oxygen here, so this is going to be 6 times Z plus W. Okay, and there we end up with 4 equations. Okay, now how many unknowns do we have? We have 4 unknowns, right? We've got to find the coefficients for each one of these so we can know in what proportions and what amounts we need to start with. Okay, so if we figure out these, then we know how much we need to start with and how much we're going to end up with given that. And so notice how we have 4 equations with 4 unknowns. So we'll talk about that later. So now we've got a system of equations where we can solve for x, y, z, and w. Okay? And there's your two examples of where linear algebra is used. See you next time.